Hello and welcome to Sean White's Solar and Energy Storage Podcast. Today our very special guest is John-Ross Cromer of Sol-Ark. And I've seen John around at a lot of different solar shows for a lot of different years. And finally we get him here on the podcast and we're going to learn all about Sol-Ark inverters. And I know he used to work at Fortress Batteries also. And I was just wondering, just to start it off, is like, why are so many companies using Sol-Ark? What's the deal with that?
Yeah, thanks, Sean. Thanks for having me on. Sol-Ark, we call it the pioneer of hybrid inverters. And it's a controversial statement because hybrid inverters were around before Sol-Ark, but the definition of hybrid inverter has evolved with time. I think Schneider was the originator of the term, where they defined a hybrid inverter as being a battery inverter that you could grid tie and charge from the grid and sell back to the grid, but there was no solar component. Sol-Ark in the United States has led transformative hybrid inverters that were solar plus batteries combined. And for a long time, no one else did that. And now we see, like with the Tesla Powerwall 3, the industry moving towards hybrid inverters, especially in the residential market, some in commercial. When you tally it up, hybrid inverters have over tripled their market share just in the past couple of years. I think that it is as significant an industry transition as MLPE with microinverters and DC optimizers, at least in the residential segment. So Sol-Ark has kind of gotten in early to the game and has been shipping and delivering hybrid inverters and large whole home backup hybrid inverters since 2018.
Cool, yeah. And I kind of explain what a hybrid inverter is to my students as saying it's pretty much like an inverter that you can plug batteries and PV into. Does that sound about right?
That's true. I think Sol-Ark takes it a step further and really tries to define what an all-in-one hybrid inverter is, which is sort of like an all-in-one computer. It has the screen, it has the hard drive, it has, everything built into a single unit. For Sol-Ark, with an all-in-one hybrid inverter, we build in a lot of the interconnection hardware that many others, our competitors, have an external MID panel or external AC combiner. We put enough hardware into the inverter unit itself so that you do not need to use those techniques for at least your standard projects.
Yeah, and that was another thing that happened with the 2023 NEC is in the informational diagrams that they actually moved to Article 705, they show you now with a microgrid interconnect device that could be inside of the inverter. And it was always there, they just didn't show you that before.
I love it. When I need to explain what the Sol-Ark hybrid inverter is, I can just go reference the diagram in NEC. There's a lot of utility that can be squeezed out of that. I view it as National Electric Code defining what a DC ESS is, because there's a lot of, is a DC ESS a DC only system with no AC component? Well, here in National Electric Code, we have a definition of a DC interconnection with an ESS pictured in an AC hybrid inverter alongside. So it signals to manufacturers, as far as the UL listings, that yes, it is possible to have DC ESSs that are listed independently of the hybrid inverters. And the installers in this space know what a painful learning process it's been with UL 9540 revision 1, 2, and 3 to kind of get to that consensus.
Yeah, we did have Sequoia, who you probably know from Briggs and Stratton or Simplify. They're kind of the same company now. And right after I first saw their DC 9540 energy storage system, and they were using it with the Sol-Ark inverter and all their examples and things like that, but it's less expensive for them to list it once to UL 9540 and then have it work with different inverters that way. So I thought that was pretty cool. And I think I've seen a couple other battery companies do that too. You probably know more about which battery companies those are also.
There's certainly a strategy behind that because, sometimes it's easier for the inverter to be considered part of the system, like an ACESS. I think the intent by UL trying to restrict DCESSs was to bring attention to bus bar sizing and proper bus bar control. With Sol-Ark, you often do not need a bus bar because our inverters have two battery ports. So the combining is either commonly included on the battery side listing or within the two battery ports. But I mean, the mistake that UL was trying to bring with the DC bus bars, most bus bars are simply not rated for the short circuit current interrupt rating necessary to combine more than two lithium battery stacks in parallel. So they were pointing that out, but the whole time the industry was saying, no, that's the role of the designer is to properly design the system, and there are solutions out there where you can incorporate the busing into the DC ESS listing. So let's get that put in. So for those needing the history lesson, DC ESSs were allowed in UL 9540 Rev 1, and then in UL 9540 Rev 2, they were removed as a concept. And then in 9540 Rev 3, they were put back in to say you can independently list. So it'll be a few years before the industry comes to alignment on all of that.
Yeah, the NEC has had some confusing definitions as far as hybrid and as far as an energy storage system. So the energy storage system definition that they still have right now says that the energy storage system is able to supply the premises wiring system, which is kind of weird for DC because we don't have DC houses, or maybe there's somebody out there that does, and I don't know of anybody that's actually used a DC energy storage system to supply their premises wiring system. And then another one, it would be microgrid. That's another definition that's a little bit confusing because a microgrid should be able to connect to and disconnect from the primary power source, which is the utility. And what if you're not near a utility? I'm looking at an island right now because I'm in Panama, and it's like if I have a little microgrid out there, maybe I can't call it a microgrid because they do use the National Electrical Code here, but they call it the NEC. And then the other definition that's a little bit confusing, and they did change it, is they had the term hybrid in the NEC, and I think it was last seen in the 2017 NEC. And a hybrid, it wasn't hybrid in terms of inverter, but it was in terms of a system, a hybrid system. And a hybrid system specifically did not include batteries or the utility. So it was something like a PV system that would also use either a generator or a wind turbine or micro hydro, something like that, specifically said not a battery. And everybody says hybrid inverter and they mean PV and battery. And that's just what everybody says. Just like when they say solar panel, they mean solar module. And they eventually just got rid of that hybrid term, and they did get rid of the term solar panel because it was just mixing people up.
Yeah, and so I firmly believe that Sol-Ark's contribution to the industry, since it was actually founded in 2013, but its current product series came out in 2018. I think its major contribution to the industry is kind of changing that vocabulary to where no one was using hybrid inverter. The hybrid inverter was really, if being used, it was applied to battery-only inverters, and now no one considers hybrid inverter to be battery-only. They all consider it to be solar plus batteries. And with Sol-Ark, we don't incorporate the battery into the inverter itself. That is another peculiarity compared to, say, Tesla, where the battery and the inverter are combined. But what that allows us to do is focus on making the largest inverter possible, for a residential application. If you scaled up the combined, the inverter plus battery, if you scale that up to the size of the inverter that Sol-Ark's making, it would be too heavy to move around. So we can focus on making the biggest inverter possible, one that is suitable for 200 amp service, as most, a 10 kilowatt inverter is not a 200 amp inverter. And then it also allows the battery manufacturers to make the best batteries that they can, whether that means feature set or price point, to combine with the inverter. But if you start messing around with fundamental terms and fundamental tenets of the industry, such as the battery and the inverter could be separated, and that the battery might include all the safety provisions needed to get its 9540 listing, suffice to say, UL 9540 Edition 2 threw the hybrid inverter industry for a loop. And then involvement, we always talk about code being, overly regulated, but I think that it's a great example where the industry got involved, provided feedback to the CEAT committee, and got the DCESS flag planted back firmly on solid ground with Rev 3.
Maybe you could talk a little bit about these different revisions. So you said Rev 3. Maybe we could start with 0? No, there's probably not a 0.
I'm not sure there's a 0, and I might get revision
-1?
versus addition wrong, but it was almost like the Rev 2 was like the Helen of Troy moment that launched 1,000 ships, because up to Rev 2, you had your inverter manufacturers and your battery manufacturers in collaborative relationships. Rev 2, by getting rid of the concept that the batteries could be listed independently of the inverter, it really forced the inverter manufacturers to become battery manufacturers, the battery manufacturers to become inverter manufacturers, and what were collaborative relationships became competitive relationships. So it's nice to kind of see the reset button being pressed with Rev 3 to say, no, you can have batteries listed independently and wired up to inverters. And it's very nice to be able to go into National Electric Code and reference that DC interconnection, that DC ESS interconnection example as a guide to the inspectors who are trying to navigate that process. Of course, the issue is with code cycles, the inspectors go to training, and then what they're trained up on is the previous code cycle. So if you have dramatic changes from one code cycle to the next, it can get very complicated for those transitory years. I think the battery code is much more aggressively evolved than solar back in the day.
Yeah, so these different revisions like UL 9540. So UL 9540 is a UL test. It's a test for equipment. It's different from the National Electrical Code and things like that. And so there must have been UL 9540 Rev 1, which we would have just called UL 9540. And this is different from UL 9540A, of course. And then there was Rev 2, and then I guess it's Rev 3 will allow somebody to have a DC-only energy storage system is what I get.
It's more that they allow the battery side to be, if the batteries include all of the safety features necessary to get through 9540 listings, that they are allowed to be listed by themselves, and therefore they could be paired with any inverter.
When it's coupled with a DC UL 9540 energy storage system. Is that right?
That is correct. And there are more ideas and concepts such as, well, maybe if the inverter doesn't need to be grid interactive, and so it's not 1741 listed, then perhaps the inverter could be only incorporated in the 9540 listing and not be part of 1741. But that isn't usually how it plays out, because the market is, even though there are plenty of standalone applications, the market's a grid-tied market.
I think even standalone needs to be UL 1741, even charge controllers. So I think even combiner boxes need to have that. And so I have another idea for you is, when you're putting more things into the inverter, so you've got the inverter, you've got the charge controller, you've got the microgrid interconnect device, why not throw a washing machine into it?
Well, we have basically a bonus port, which is a very robust extra port for you to throw on whatever you want. And that could be AC coupled solar or a generator, or just, I like using it just for a sub panel. If you have an outdoor panel and an indoor panel, that extra port is useful for solving all kinds of interconnection design challenges. So, if you want to connect your washing machine directly to the Sol-Ark inverter and only do laundry when your battery's at a healthy state of charge, that is possible out of the box.
So is it a 240 volt circuit?
It's a 120, 240 GIN port.
Awesome.
You can run a 240 volt load off of it.
So would that be something that people would be hooking electric vehicles up to that could do some kind of like energy management so it could throttle down the EVs?
It is, but with EVs, I feel like the customers' imaginations are still kind of ahead of the market for the time being. I think 2025 will be a big year for EV to home, but there's a lot more complication with EV to home and stationary ESS systems in terms of them working together in concert. And what we offer at Sol-Ark right now, what we would advise is to keep it simple and just to utilize EV backup. And then if you want to incorporate EV to home, adding in some additional balance of system material to help direct that properly. Because you get into issues, well, which is the master inverter now? Is the car the master inverter, or is the system that's always on site the master inverter? And then it's,
Okay,
well,
yeah.
if the,
Uh-huh.
yeah,
I was thinking
I,
of just like my EV, which is just a load, but yeah, it's very important to have the bidirectional EVs working, and we're barely starting to see that right now. So,
yeah. So pragmatically, when there is a disaster, like when there is a long duration power outage, what customers want to do is be able to charge up their EVs and get out of Dodge. And what they leave behind is the infrastructure necessary to power their house in a kind of a lower energy mode of operation. But customers in their imagination, there's a disaster going on outside. They want their car to also charge their home. And that is a possible design hurdle, but only one I would recommend to advanced designers in 2025. I think by 2026, that issues of EV to home should be much more abundant than they are today, more reality than concept.
yeah, because also, like, say somebody has a 100 amp service, they can't just go add an EV breaker because with the Article 220 load calcs, it can't take, another 40 or 50 amps. So throttling down the EV can be important, like with the energy management system.
Well, I would say that's a great use for Sol-Ark because you can put the Sol-Ark on the wall and utilize the gen port for
Oh,
additional point of interconnection. And all Sol-Ark inverters are listed as power control systems. So
oh,
they can
great. Oh,
actually
so it does
regulate
that.
the,
Awesome.
yeah.
So
Yeah.
it totally does that. Awesome. Okay.
Yeah, Sol-Ark, our inverters are probably a little bit more expensive than your market rate, but they include a lot of stuff under the box that the age-old argument of reduces balance of system material, speeds up installation time, that sort of stuff.
Yeah, and so maybe we could talk a little bit about power control systems. And so you have 705.11 in the National Electrical Code, and that's for supply side connections, or in the 2023 NEC, they changed the name, source connection to a service. And then they have load side source connections, which is 705.12, which is like backfeeding a bus bar and all that kind of stuff. And then you don't have to use either one of those, 705.11 or .12, if you use 705.13. And in the 2020 NEC, it is called Power Control Systems. In the 2023 NEC, it's called Energy Management Systems. It's essentially the same thing. And it's a way of controlling things so you don't put too much current on a wire or a bus bar, rather than having to just size your breakers and your bus bars and things like that. It's using smartness, brains, CTs, which measure current. That's a current transducer, and communication, so you don't overload a conductor. So maybe what it could do is slow down your EV charging if there's going to be too much current going that way, or slow down something else. Turn off your washing machine for a little while, or your air conditioner.
Yeah, the often we think of National Electric Code as being very conservative, and it should be. It's a safety code, but the 120% rule, that 70512 load side interconnection, that was actually like a concession. That was okay, you can connect 240 amps to a 200 amp panel if you do it in this particular configuration. So that, to me, that's not being conservative. That's being, understanding and somewhat aggressive in allowing, more power to the bus bar to be interconnected. But as time goes by, the inverters get larger and larger, and then the 20% or 120% rule becomes kind of, less relevant. And PCS evolution 70513, allows so much creativity of design and design flexibility. We've gone from homeowners want whole home backup. They don't really want a central load panel. But now with the PCS listing, load side connections of very large systems are possible. And that can be a critical part of interconnection strategy. I think of it for residential, yes, but also with commercial. It's not very commercial. Sometimes it is much easier to do a load side connection. Sometimes it's much easier to do a line side or supply side connection. These PCS listings basically say you can do your project and we can work around the interconnection. And yeah, as long as you're listed to monitor everything and keep it below the listing of what has been the main service panel, but is what is being expanded to, like sub panels and conductors between them and a partridge and pear tree. If you can control the energy through the system and you are listed to do so, then we'll give you even more allowances in your design flexibility.
Yeah, so with 705.13 power control systems, energy management systems, you can theoretically have 1,000 amps of inverters connected to a 100 amp service. And it's kind of makes it look like the service where you're getting electricity from the utility where they're serving it to you is just another power source.
Yeah, and we have designers and integrators who use our systems to try and figure out ways to take advantage of that to provide large amounts of power to end-of-line service where the utility wants to deliver a smaller service size because they simply don't have, it's very costly to push large amounts of power out to rural areas.
Yeah, and so it's pretty cool how all that is working. So people should be keeping an eye on EV to grid and energy management systems, also known as power control systems, 705.13, and Article 750 is energy management systems. And not only are we controlling sources with our inverters, but loads too. So just like everything needs to get coordinated. One of the places where they've been doing this a lot is with large commercial EV charging. So you have 10 EV chargers, and if there's only 5 cars there instead of 10, perhaps you can charge those 5 twice as fast, and you're not going to overload conductors and things like that.
That is true, but kind of a parallel industry running into, like, now there's all these creative things you can do with interconnection. We're seeing, especially in commercial, with EV charging even, the logistics of tying the system into the building being so difficult in a parking lot that wasn't designed for it, that the parallel path is a lot of customers just say, we're not going to interconnect at all. We're going to do a off-grid system. The humor of it being that off-grid, in my mind, is a cabin in the middle of the woods. But really,
that's the way to do it. Yeah.
A site alongside interstate might be an off-grid system just because the logistics of doing the grid tie are too much for the project and not needed for, the precise amount of power. Keep it off-grid. So off-grid systems now are inside of cities, not just for the countryside.
Yeah, and I have heard that most new commercial EV charging that's being installed does have energy storage affiliated with it. And I have seen places where I plug in my car where there's 30 chargers or something like that. And they have megawatt hours worth of energy storage systems there that I get to go walk around and look at. And it's just because the transmission to those chargers isn't enough for the peak times. And so they're still connected to the grid. They don't have solar with them where I was talking about. So they're really grid tied, but then they can charge them at the off times when the cars aren't all pulled in there right after work when people are going shopping.
Sure. The advent of commercial batteries has really reinvigorated energy projects for commercial project spaces. It's what I am most excited about right now for the future is the commercial market. Whenever I have a sales manager, from industry asking me, hey, my particular residential installation company or, residential manufacturing is very competitive. Where's the next big market? It's like, well, commercial, behind the meter commercial right now is a very accessible market and a explosive growth market for historical reasons.
Yeah, and it's kind of funny. We were just talking, I think 2 days ago here in Panama, where they have the exact same electrical grid, and we were talking about Sol-Ark inverter. So your commercial inverter. And so I was wondering maybe if you could talk about, what are the different AC and DC voltages of the Sol-Ark inverters from, commercial to residential to all of them. They sometimes talk about low voltage and high voltage DC, which, there's lots of different definitions for high voltage, and we're not talking about 35,000 volts or anything like that. That would be fun. But maybe, I'm sure you know exactly what the voltages are, so maybe you could explain it.
Yeah, I mean, the utility stakeholders will look at how commercial or residential uses high voltage and laugh because it's, they deal in, tens of thousands of volts. And for, residential installer, high voltage might be for batteries, anything above 48 volts. And,
Yeah,
we
I
make,
tell people if they ever say medium voltage, that's really dangerous. But when sometimes people say high voltage, yeah, like you're saying, they might mean 240 volts. But according to somebody that works with utility lines, I believe it's 35,000 volts.
yeah.
Uh,
So we make inverters more for, secondary service beyond the primary transformer. We make 480 volt three phase. We kind of have a unique 208 volt three phase inverter. And, anything beyond that, there you would have to engage directly like with our Latin America team for a little bit more of three phase options beyond your 208 and 480.
I mean, they're doing exactly the same grid as the US right here. And I know in different places, Latin America, it's different. So explain to me again, what are the three-phase voltages on the AC side?
It's 480, and that can be done in a delta over Y configuration.
Great.
And then
So you could
208
do
three
like,
phase.
can you do ungrounded delta 480?
Yes.
Oh, wow. Okay. And so you have like every different option. That's pretty amazing. What is it, 60 kilowatts? Is that what the inverter is?
It's 60 kilowatts backup, but
Hmm.
just like our residential inverters, they have the 200 amp pass through, and that's
Uh-huh.
stackable. So, on a 2000 amp service, you can have 10 inverters in parallel configuration passing through the full 2000 amps from the grid, but you would only have
Wow.
600 kW of backup capability.
Wow, that's pretty cool. So are all the Sol-Ark inverters, they all have 200 amps that they can pass through?
They do. The 15K residential, the 30K, and the 60K all have this 200 amp pass through capability. And even if your application doesn't necessarily need the full 200 amps, let's say two inverters on a 200 amp service, basically that's your grid relay. And it's not a bad thing to have your grid relay be oversized,
Yeah.
particularly when you're doing parallel string inverters to mitigate, damage done to the relay during transfer time.
Yeah, that's
Helps.
pretty awesome. Because I remember like back, I don't know, 10 or 15 years ago, that was the big problem with doing backup. And so people weren't really using microgrid interconnect devices except for the ones that were built into the inverters. And they were like, what, 60 amps or something like that?
It was incredibly difficult to do battery-based design before either, what is just brand new to the market today, these MID panels, or Sol-Ark bringing that functionality into the inverter itself. The difference would be if you were doing a new construction design and you could only go up to four inverters in series with a particular inverter model, and turns out the home gets built and the electrical scope grows, your whole design is rubbish at that point because you've exceeded the capabilities of what the products on the market could actually deliver. Basically, off-grid design in years past was more like small home, energy efficient home, more like living out in the Alaska wildlife with very small amounts of energy. Now, whole home backup, you almost don't even need to worry so much about power because the inverters are getting so large. You can just tell the customer, well, when there is a power outage, just be aware of that. Do your laundry and cooking during the day. At night, you'll get through with just your base load and air conditioning.
Pretty cool. And so we talked about the AC voltages, and it seems like it has about every common AC grid voltage from 480 delta down to 120, 240. How about the DC voltage? What are the different DC voltages for the different inverters?
Yeah, the Sol-Ark product line differentiates itself in that the residential product is 48 volt nominal, or in lithium world that might be 51 volt nominal, but regardless, it's made for 48 volt batteries. And the
Yeah, and a
the
lot of people
reasoning,
use that definition. So if you go take 3.2 volts per cell for lithium iron phosphate times 16 in a row, you get, what is it, 51.2? Is that what it is?
yeah, there's a range,
And,
and
and it's
some
close enough to 48 that everybody calls it 48.
And the point is, it is still the most standard residential voltage for batteries. And when the batteries go dead in my television remote, I just swap the batteries out. And so the issue is, well, in 10 years from now, the customers may want to swap out those batteries. Do they have to get rid of the whole system, or do they have to replace the batteries? And having that standard means that the Sol-Ark customers are set up for the future, in the sense that there still will be 48-volt batteries on the market 10 years from today, whereas going with a more custom higher voltage bus would mean that it's not necessarily that the manufacturers using higher voltage batteries will be out of business in 10 years. They won't be. Companies like Enphase will still be in business, but will finding a replacement battery fit the 10-year-old architecture becomes the challenge. So residential, we keep things safe and standard at 48 volt. By the time we get to commercial, Sol-Ark actually makes its batteries for the commercial market, and we go with more custom built higher voltage. That might be around 500 volts for 208 volt three phase. It might get up to higher voltage like 800 volts for 480 volt three phase. It depends on your electric service.
Yeah, and I've noticed a lot of times they call them LV and HV for low voltage and high voltage on the DC side. And somewhere around 48 volts is the LV, not Louis Vuitton. And somewhere around like 400, but you were even saying up to 800 volts is going to be the HV, the higher. I always don't say high voltage, I say higher voltage.
And what we see is that for us, it depends on our inverters. Our 208 volt inverters run at a lower battery voltage than our 480 volt. And so you want to kind of somewhat match up your battery voltages to your service voltages to keep your conversion efficiencies in check.
Yeah, and of course your inverters work on grid and off grid, and they work with lithium ion batteries and lead acid batteries. They probably work with other batteries too. Do you see people using like nickel cadmium or nickel iron or anything like that? It's probably pretty rare.
It's rare, but we do have battery partners using fuel cells and using lithium titanate. And, it seems like sodium batteries may make another run at the market in the near future. But whenever I'm looking at industry trends, I just think, well, what did the solar industry do 10 years ago? And how might that compare to what the battery industry is doing today? And I sort of see lithium like monosilicon or polysilicon. They're just going to compete based off, already being the most popular battery chemistry on the market and having the economies of scale to keep pushing the boundaries and keep driving the price down. So there are other battery chemistries on the market, but I'm not sure if most customers need a 20-year or 30-year battery, if it might be in their best interest to go for the 10-year battery that has an easy swap to kind of keep affordability in check.
We interrupt you for a very important announcement. Sean White's Solar and Energy Storage Podcast has been brought to you by Sean White's Solar and Energy Storage Podcast. That's right, Sean White is sponsoring his own podcast, and he wants to remind you to go check out some of his classes. You can go to SolarSean, that's Solar, SEAN.com, and then click on the links to check out his classes. You can check out his heat spring classes, and you can also hire him to teach classes for you, like at your company, something like that. Now back to the show. Have you ever seen the YouTube video where the guy takes like 1,000 lemons or something like that, sticks a piece of copper and a piece of zinc into it like a penny and a nail, and he gets some voltage there? Maybe we could do that with the Sol-Ark inverter, make it lemon powered. But then, would we have to get the lemons listed? Like, do you think?
That would be your UL 9540A cell level test where you could pass it. And that would allow you to put your lemon battery or your potato battery inside somebody's bedroom or kitchen, because it wouldn't, during a house fire, it wouldn't add fuel to the fire.
Yeah, and I think the kitchen is the best place, because what happened at the end of that video is they figured out they could get more energy when they were done by turning it into lemonade.
That's every commercial batteries, at least, you need to have a decommissioning plan, and that would, that'd be one easy to we have our garbage disposal. We'll just chop
Yeah,
it up,
sure.
have some breakfast. You know.
I like that. A lemonade decommissioning plan.
Yeah.
That's a
Yeah.
great idea. I wonder if the lemons are sweeter when all the electricity is out of them.
Yeah.
But then you
Employ
get a
some
little
kids.
zinc, copper. It's probably all healthy, you know?
Sure.
All right. That's pretty cool.
I
So,
think on 48 volt for residential is by the time you get to commercial, the battery banks to get the power you need, the amperage is too high. And so you'll run out of ability to combine batteries in parallel at 48 volts. So commercial is kind of forced into the higher voltages one way or another.
and so what I think, what I've heard, and it's like I haven't broken it open yet, but with those higher voltage batteries, they're really just DC to DC converters in there. It's not like they have a whole multitude of cells in series for that.
Well, I think that you can do both, and I think
Mm.
it sort of depends on whether you're like a utility scale application trying to, get the voltage up as high as you possibly can to go into your primary, or, I see that the DC to DC converters have been a common failure point in the industry. And when we do our batteries, there's not any active DC-DC boosting going on. It's just native
Oh,
series wiring. There is some protection in there. There's cell level monitoring and BMS and all that, but it is stacking it up in series without,
okay. Huh.
a DC to DC conversion to higher and higher DC voltages.
And of course, overcurrent protection is going to be built into those batteries. So for the 800 volt battery, then are you saying that that 800 volt DC battery has got a whole bunch of cells in series and it's not doing DC to DC conversion?
That's right. So we'll have 12 batteries and they're about 50 volts nominal each. And, that'll get you up to about 600 volts rather than
Oh,
800.
wow. Okay, so that's what you're doing for your 60 kilowatt, 480 volt inverters, I guess.
Yeah,
Okay.
we have indoor and outdoor battery cabinets and slight nuances, slight wiring differences between 208 and 480. But with the
That,
481, 12 in series, stacking up the voltages. For the
uh-huh.
208, it's more like you have two blocks of six in series.
Is Sol-Ark making any batteries?
Yeah, the role of a U.S. manufacturer who produces their products, using global manufacturing, that's a tough definition in terms of what make means. And so I would say,
Huh.
yes, Solar does make its batteries just like a solar module manufacturer might make the module, but not necessarily the cells. So we don't make every single part, and then we use contract manufacturing to make the batteries. And so I find the industry struggles with, well, what is like the definition of a manufacturer? What separates a manufacturer from just someone who slaps a label on the side of the product and calls it their own? Even the do it yourself community has a hard time differentiating this, but it comes down to, well, how much of that production line do you own? Is it used to make everybody's product in the industry or just your product? Is it in full-time operation, or does it wind down and then get used for other things and then wind back up, at the point of production?
Okay.
Our system, it's our product line, it's our 24/7 production facility that's not used to make any other batteries except our own. And so that is what global manufacturing is. It's too complicated for the consumer to appreciate. What the consumer needs to know is there a support line you can call? Is that support team, how well supported is it? We've seen ESS companies kind of ramp up support and ramp down support. We have over 3 dozen support personnel out of our headquarters in Texas. So, it's consumers have to lean into bigger brands if they want their products to last a long time and be well supported. And
Okay.
so that's what Tesla does, Enphase does, Sol-Ark does.
Okay, because I'm used to seeing Sol-Ark inverters being used with different brands of batteries. So that's just what I see all over the place is, so you have your own battery.
We
Like,
like
it's a,
battery choice. We think that battery choice benefits the
mhm.
consumer, but by the time you get into commercial projects, there's too much money on the line. Like residential, the benefit of battery choice is there's so many different kinds of batteries to choose from. There are really easy to install stackable batteries. And then there are more difficult battery systems for one reason or another that tend to compete on price point, which price is key, right? That is the
Hmm.
primary decision maker. But then there's other features like rapid shutdown for batteries, which some jurisdictions are kind of getting ahead of code on.
Yeah,
There are
emergency
battery
shutdown. Yep.
yeah,
Yep.
and
Uh-huh.
there's battery heating systems which are not needed in all parts of the country but are super critical in certain geographies. And so by the time you get to commercial though, like you don't want anything to go wrong. You don't want to have to be an expert in two different companies. You need, one throat to choke. And so despite our fondness for battery choice and us focusing on making a good inverter and letting battery manufacturers, make great batteries, we do kind of streamline it for our commercial product offering.
Great, great. Okay. Well, good. Thanks for letting me know about all this really super cool stuff that you guys are doing over there at Sol-Ark.
It's crazy, Sean. The commercial market is so exciting in terms of its growth opportunity that by 2025, Solark will be half commercial in terms of its revenue. So pretty dramatic given that our commercial product line is about a year and a half old at this
Uh-huh.
point.
What's the biggest commercial project that you're doing right now?
There are, I can't give you the exact number, but I would say over 100 commercial projects a month. And
Uh-huh.
I simply cannot keep track of them all. I am sure that there are some that are doing 10 inverters and trying to max out the system. I don't know of anyone who's pushed us to our 480 volt. We can scale up the batteries to about 10 megawatt hours. I think by the time you get to that, you're moving into containerized solutions. Most of our commercial sites are one or two inverters and then 1 to 4 battery cabinets. They're
Okay.
targeting small behind the meter, a little bit of commercial backup, but a lot of rate optimization.
Maybe someday I'll be seeing some Sol-Ark, container batteries or something.
I think so. I mean, I think there's so much flexibility, and we have kind of a unique first to market position in small to mid-sized commercial, whereas there's a lot more competition in containerized. And then also the trend in containerized that I see is vertical integration, where the cell manufacturers are getting into supplying the containers. And to be a cell manufacturer in this industry, you really need to have a tremendous governmental subsidy, and I don't think that we want to do that either. So, what I like is Sol-Ark has this behind the meter focus. We do have integrators using our projects to make microgrids. As far as the largest Sol-Ark system goes, it's probably one of our project integrators building microgrids where you have, 100 interconnected systems to form, a community grid.
So multi
Um,
megawatts
yeah, there are
and
there
megawatt
are
hours.
communities in the Bahamas, for example, that are just getting rid of their diesel grids, pretty much entirely to replace them with our solar battery systems. Can't do that in all geographies, but some geographies works out just fine.
Do you think that with the Sol-Ark inverters, that theoretically, if you had, plenty of money and stuff like that, that you could have a whole country, like a normal sized country, or a whole grid that's all inverter based? Like, so you always hear the talk, like we've been having some meetings here about, like, oh, if we go over 2% solar, that's going to crash the grid. And of course, that's not the case. A lot of times they put some percentage on it, and I always think that we do have the technology to go 100% solar, or 100% renewable, or inverter, or something like that. And there's, I guess there's not really a need for it yet because we're not quite there. But theoretically, perhaps you could just network a whole bunch of these things together with a whole bunch of batteries, and even like a place like the United States, if everybody had a Sol-Ark inverter and a big battery, how would that work?
I think it would work fine. I do think we can be 100% solar society. Okay, there will be some other forms of energy providing some secondary backup, but
No, we're going to make that
um,
illegal. Yep.
I think that a more pragmatic and realistic goal that people can kind of rally behind is 100% daytime solar. It's, well, let's focus on getting to 100% daytime solar and celebrate that milestone and use batteries to kind of balance out the daytime solar production to deploy it when it's needed most. I don't think there's anything stopping it in the long run. And I look forward to that Star Trek universe where we go beyond 100% solar and have so much energy that it starts to transform society beyond the energy sector.
Yeah, I think Star Trek is actually true. And they came down and then they just like took over and they started doing some of the writing. So, yeah, the aliens. Yeah. So, one thing that's kind of interesting that I'm just thinking about right now is here I am, I'm like at the Pacific end of the Panama Canal, and I'm looking at like, I don't know, maybe 100 container ships with like, I don't know how many hundreds of thousands or a million containers. And I'm wondering how many Sol-Ark inverters and other inverters and batteries are inside of those ships. And then I was even thinking about the name Sol-Ark, so Noah's Ark. You probably know Noah, he probably works there. And so this canal went through a place where it used to be land, and now there's big ships where there used to be land, sort of like Noah's Ark. And there's probably some of that going on with some Sol-Ark inverters, inland, in between the Atlantic and the Pacific right here, where a good percentage of the world trade goes. So that's pretty cool. And then another thing about the word Ark or Noah's Ark and things like that is it happens to be common with three of the big religions in the world. So they all hang out with Noah. He's not as controversial.
Yeah.
And so things like that too, you want to bring people together because people like to kill each other over having like a different religion and stuff like that. But we need to just see what we have in common. We all have sunshine in common, and we all have a need for inverters and batteries and solar PV and all that kind of stuff.
Well, if we remember at the end of Noah's Ark, God promises not to flood the earth. So if we see ocean level rising, we know it's on us this time.
Okay,
So,
all right.
and,
So
and
everybody better turn on their PV systems and get more batteries and get this whole thing working together.
yeah. And I think right now that there's kind of a trend towards not having, collaborative solar policy that's more of a societal, it's hard in the United States, net metering's on the decline. I think right now a lot of the buyers are buying systems more to look after themselves than society because they're faced with aging grid infrastructure, needing to secure their own energy for their specific families. So build a boat or build a Sol-Ark.
All right, yeah, and I think too, just like getting all these things to network together with our power control systems, energy management systems, that's going to help everyone.
It sounds complicated, and I can understand as a customer if you hear, these technical podcasts, you say, how am I ever going to learn, about all this stuff that I have to learn just to be a solar owner? And I think there is a learning curve right now that's being climbed as batteries come into the mix. I know you go way far back, Sean, in the solar industry. When I got into the industry, it was 2008, and I was working for an oil and gas company called Fluor. And Fluor had won, what was one of the first major, I don't know if it was gigawatt yet, but major contracts to build solar module refining plants for REC silicon. I think it was like just the construction of the first phase was like a $500 million silicon refining facility, and plants of that size had not been built prior to that. And so I was working for Fluor and researching their effort into the solar market. And I read a side note that someone in marketing had appended to a summary of the silicon business unit. And the note was, solar is so simple to design that as a company who bills by the hour to design and build power plants, by scaling up the solar industry, they might actually see a decline in revenue in the future because there's the simplicity to build a gigawatt sized power plant is so much more simple than a traditional power plant of equivalent power capacity. And I felt like, well, if a company full of thousands of engineers is sort of scared, even if it's a tongue in cheek kind of reference, if they're sort of scared of what one engineer could do compared to 10 in the solar industry, I wanted to be ahead of that curve rather than behind it. And so that's when I jumped in. And I think that has borne out today, too. I mean, we see new energy additions to the market being solar based and the projects going up very quickly. And now we have this battery wave that is re-energizing the market, particularly in the commercial market space. I think that the learning curve should be climbed. I think it's going to benefit the workers in the industry and also be more in line with what the customer's imagination expects when they hear about solar power. So I'm pretty optimistic about where the industry is heading, even though it is a painful process to transition away from net metering.
Yeah, and I guess all the policy experts out there that are making the policy, make it so it's gradual changes. I always say that, but when they just make a huge change like they did in California with going from net metering 2 to 3.0, it just caused a lot of unemployment because it was such a sudden change. They need to have like 2.1, 2.2, like kind of gradually get you there. So
yeah, this is what I love about the commercial market in particular. It never was there. The commercial market could not participate in net metering because the energy charges were only a fraction of their total bill. And so in 2008, it was a unique year because the commercial market for the first time had grown larger than the residential market, and the utility market still wasn't really a thing in 2008. And so the commercial solar market was the biggest market segment in 2008. Well, then the tax credit gets uncapped, so all the money goes from commercial into utility scale. Net metering is on the climb, so the residential market continues to grow. The commercial market lagged behind and became the smallest market segment, not the largest, in the past 10 to 15 years. Well, now it's like a slingshot. It has missed out on the solar growth of the solar boom of the last decade, but batteries are filling that missing piece to the puzzle and unlocking. If you have demand charges, the battery provides more value than the solar array does. And so now what was empty marketplace is now, one of the best markets to be in is behind the meter commercial, because in residential, a lot of low hanging fruit has already been picked. In commercial, it's ripe and ready.
great, yeah. And then just for people that don't know, demand charges are charges for power, which is the rate at which we use electricity. And we're usually used to having energy charges, which is the quantity of electricity. Yep. And so, so it's great. Thanks for making all this happen.
Well, it's the decline of net metering means that it is no longer easy to design solar using pencil and paper, because especially without batteries, 2/3 of your solar production or more gets sold back to the grid. And now that there's no longer kind of a 1-for-1 exchange of what you export is what you get, just tabulating the economics becomes something that you have to use a computer for. So, design continues to evolve. I still think it's possible to do preliminary analysis off a single electric bill, especially utilizing the advantages of some things like grid pass-through, where you don't have to worry about sizing the system for the entirety of the service. But definitely still more ground to mill in terms of future project opportunity.
Great. Thanks. So let's see, is there anything else that you want to talk about or cover?
Well, I would like to, running training at Sol-Ark is my day job. And we do 2 webinars a week, generally. You can find them on LinkedIn. So if you like solar discussion, jump into a webinar. We make them very topical, so find a topic you like and jump in. I do want to give a shout out to my sizing tool, which is a side project. It's not really a commercial endeavor, but I just got so frustrated with how hard it was to design solar in a post-net metering environment that I homebrewed Excel sheets into a web app that people can use.
Wow.
And it's called PV Bats. So it's pvbats.com. It's like PV Watts, but for batteries.
Oh, okay, cool. Like PV Watts, PV Bats. So PVBATTS?
Yeah, .com.
Okay. Awesome.
And it's the whole premise behind the sizing tool is that you can go from a single electric bill to a rough outline of what's the right amount of batteries and solar to sell. And I think that, to me, with net metering, it is more of a software crisis than anything else, because the whole industry was focused on net metering without batteries. None of the software incorporated batteries. The installers don't know how to sell the value of a larger battery bank. And in some cases, the larger battery bank, it doesn't improve the economics, it just improves the reliability and power outage protection. So without quantifying that reliability metric, how can you sell it? And by simulating, thousands and thousands of different battery combinations and solar combinations, what you can discover is the difference between, a solar battery system needing to use the grid every single day to a system only needing to use the grid every other day for half the year. The difference in battery capacity might only be 10 kilowatt hours. It might be the difference between storing, if you store half of your energy use in a battery, you're still going to need to use the grid every day. If you store 75% of your daily consumption in a battery, you'll get through every single sunny day from sun up to sundown. And so getting more insight into what really makes a whole building backup system, in the imagination of the customer, so that they're happy and you can install the system and set it and forget it. I believe that that's about 75% of your daily consumption. And we haven't been there yet as the industry because of the cost of batteries. But that's what's so exciting about, the next gen batteries with your higher amperage cells coming to the market, is it's driving down the price even further. We're going to get to that point this year, I think.
That's awesome. So I can't wait to start using pvbats.com. And that's just something that you've made for free out there, and you know how to do.
It's free. Yeah.
Python or something like that? Is that what you're doing?
Well, I have another co-founder who does the programming, but you can just hop on, put in your address, put in your electric bill, and start sliding around the solar size and battery size to figure out, what's
does
right
it take
for you.
information from PV Watts, like the sunshine and all that kind of stuff?
Yeah, so I used to download the hourly information from PV Watts, and then I would take the monthly electric bills and I would chop them into hourly increments and adjust the load profile and put in the battery size and count how often I was using a generator or the grid. And eventually I was like, well, I need to just put this online, because maintaining the spreadsheets that I would give out during solar trainings was getting too problematic. There, you can also download the CSV file at the end. That's kind of a shout out to PV Watts, because I found that to be so formative for me when I was trying to learn solar design. So I love that hourly download from PV Watts. You can learn so much. You can get your ambient temperatures. You can get performance of the solar array on cloudy days. There's a lot you can extract from PV Watts. It's a good learning tool.
That's pretty awesome. I should probably be an investor. If I was a venture capitalist, I think I would be approaching you right now with my billions.
Yeah, well, not everything needs to be a business. You look at, like, say, Open Solar and how much impact they've had by giving away design software to the user for free in terms of helping the industry. And, I have a pretty good day job, so I'm fine just to have it out there as a resource for people to use.
That's cool. Do you remember OnGrid, ongrid.net, and back in the day, and it was like the software that we were using, like 20,
You're
15,
going to have
20
to
years
share
ago.
some information on that, Sean.
Okay. Well, I'm actually a guy that was one of the main guys there, Mike Bishop. I'm working with him on doing some stuff for developing a training center. So pretty cool.
Yeah. I've done solar training, but I've always stayed away from your classes, as well as like Bill Brooks and SEI, because I always wanted my content to be like unique. And I didn't want to, by taking your classes, I didn't want to skew my content and make them similar. So
you didn't want to steal my jokes, huh? No.
Yeah, didn't want to steal the jokes or the slides or the format, because I wanted to create different training content.
That's awesome.
Not have it all be the same. I used to try and train architects how to design solar in a half-day workshop, but the industry kind of outgrew that concept. It got too complicated.
Okay, well, great. Well, I really enjoyed talking to you here, and hopefully I'll be talking to you a lot more. In fact, I bet you I might even be seeing you soon at one of these solar shows like RE Plus in Boston or some San Diego Inner Solar.
Yeah,
I,
I'm doing the Inner Solar Show and then the NABCEP conference.
and
So,
I'll be there too at the NABCEP conference doing the
yeah,
PVA class.
that's my
Yeah.
favorite one. It's almost like being on a cruise ship, but you're not actually on a boat. You just
Yeah,
go
they
for
feed
a
you all the
week.
meals. They do karaoke. But on a cruise ship, though, you don't see all your friends. So it's kind of
Oh,
better
well,
than that. Yeah.
I don't know. I see a lot of friends I never get to see because the industry is still a small world.
No, I mean,
Uh,
on a cruise ship, you don't. And at the NABCEP conference, you do. Yeah. Yeah.
exactly. Yeah.
Uh-huh.
So better than a cruise ship.
Yeah, yeah. So pretty
Yeah.
awesome.
Especially if you're already in Panama looking at cruise ships all day. Be
I know
ready to go to the NABCEP conference.
I could see a couple of them over there. Yep. But yeah, I'd rather be at the NABCEP conference. Cruise ships, like being a prisoner on something that's spewing crude oil smoke or something like that. I don't know. It's been a while since I've been on one. But yeah, the NABCEP conference in Reno, that'll be awesome. And I also do really like the Intersolar conference in San Diego because the convention center is like right at the end of the main drag. And so it's just like you're walking up and down the street, seeing all your friends, and it's a pretty cool one.
Yeah, I love San Diego as a convention location. I wish they would use it every single year because
Uh-huh.
it has a great downtown area. The Philadelphia Convention Center, where I live, has just kind of opened up more for more convention hosting than it has in years past due to some union restructuring. And
Oh,
so we're starting to see some conventions being booked in Philly, and it's a luxury to be able to actually take the subway into the convention and instead of flying and
oh,
staying in a
cool.
hotel. So I'm happy to see that happen too, but there is a
Yeah,
bit of a convention mania, as well.
yeah. I remember in 2008 they had something called PV America at the Philadelphia Convention Center, and it was put on by SIA, who puts on what used to be called SPI, and now it's called RE Plus. And right when I was starting to teach for a company in Philly called Infinite Solar. And, they haven't been doing solar training a long time just because of the solar coaster. But it was some of my good times out there just watching the Pennsylvania solar rebates and especially the SRECs in New Jersey because Philadelphia is halfway in New Jersey almost, or at least the Philly metro area, South Jersey. And I've been doing some classes down there too. Next time I'm over there, I'm going to give you a call. So,
So Philly is somewhat unique in the country in that it has time of use metering options and it still has a solar net metering option, and they can combine so that even though our row homes cannot fit large solar arrays, maybe 3 kilowatts or 4 kilowatts max, you can deploy all of that solar selling back to the grid during the peak time and get a peak credit. So I love it because you can do maybe only a 30 or 35% offset, but you can reduce your bill by 60 to 65%. And, normally without those policies in place, it would not be as solar friendly.
you're making Ben Franklin proud over there.
That's right. He invented the battery. He coined the term battery.
Yeah,
So he
like from a
said,
battery of cannons or something like that. Yeah.
yeah. I did work at Fortress before Sol-Ark, and what I liked about Fortress is that they were founded to sell batteries to a regional transit company, and even 100 years prior, you could find battery manufacturers getting founded in Philadelphia to sell batteries to the railroads at the
Huh.
time. So I did like that historical connection.
Yeah, and I
Um,
guess a fortress would have a battery of cannons back in Ben Franklin's day.
Yeah, we had some fun with product names. I got started in Texas riding that solar coaster, and that's actually what got me into solar education. The rebate programs would run out of budget on January 1st. And so you'd have to shove all your rebate program applications for the entire year under the door. and go into a lottery system, see what got approved. It was very difficult. It was a great way to sell, but it was also difficult to do a business 12 months out of the year on a process so centric to one day. So my business partner and I, we looked at each other and we said, we know so much about solar, but we need to find a way to make money. So we had this crazy idea to do a one-day solar workshop. And if it would sell out in a city, we could just offer it in like 100 cities and just go on the road and teach solar all the time. And it actually worked out. So went on the road for a while. I hit up all 50 states in 1 year just because I was too. I don't think our Casper, Wyoming class made any money, but it was still good for going for the record books.
Yeah, I'm trying to think of there's a couple of states I haven't made it to, the Dakotas and West Virginia. I think those are all the states that I haven't made it to yet.
So what's great about commercial in particular is that you can have certain states that would be just completely considered non-starters for solar for one reason or the other. But then when you look at their commercial rate structures, you can say, well, a mountainous terrain generally results in higher demand charges because getting the electricity all the way up the mountain is so costly. So you have the rural combined with mountains equals high demand charges. And so even, maybe stereotypically West Virginia might not be considered, a top solar state. There are some killer applications for solar battery systems in West Virginia. And that's true for Mississippi. That's true for Idaho. That's true for Illinois. No matter where you're at, if you're a solar installer, you really need to brush up on your commercial rate structures and see where they fit into the industry, because there are if you can sell a system that has a payback under 4 or 5 years, those kinds of projects fly off the shelves.
I was always thinking that maybe West Virginia wasn't the best place for solar because they love coal so much, just like a coal culture thing, but people like saving money.
Yeah, what they want is independence and freedom from the electric grid. And, it needs to be cost effective to do so. And what I find is utilities have been really focused on how to not make solar cost effective for residential customers, but they are much slower to adjust their commercial rate structures. So historically, solar has not well met commercial rate structures. With batteries now, it's almost the opposite. It's like the best combination. And I think there's a few year window of opportunity to get in and sell commercial projects with great paybacks before utilities start to take a look at demand charges where they're imbalanced and correct their rates to make sure they're not exploitable.
Great. Well, thanks for all the great stuff that you're doing.
Yeah, it's fun. Every day in the solar industry is a good day to go to work. So, that's a big difference from starting in oil right out of college to becoming an environmentalist by working in the industry over the last 15 years. And that does remind me, there's a book called The Imperfect Environmentalist. It's a very short book, but it's about this woman in California who created the plastic straw ban. And that is only one of 10 major movements that she's been able to do by just trying to walk down the path of making the environment a better place to live, and has gone all the way to impacting corporate policy at companies like Uber with her experience. So it's called Imperfect Environmentalism, and that's another shout out I want to give.
Okay, well, we'll put that in the show notes. Yeah, great.
All right.
Okay, let's see. Anything else?
Nope, that's all for now, Sean. I've really enjoyed it.
Well, thank you so much, John-Ross Cromer of Sol-Ark, the head of training. And thanks for listening to Sean White's Solar and Energy Storage Podcast. To find out more, go to solarsean.com. Get yourself NABCEP certified and hang out with myself and John over at the NABCEP conference. Take my PV associate class there. Woo! Reno.